Good day, students. On this clip, we're going to be going over 3 examples on implicit differentiation. This video assumes that you already know, or you've already mastered your differentiation rules, such as the product rule and the rules for differentiation of trigonometric functions. All right, and also your power rule. So let's try out the first example. Number 1, find dy dx um, in the equation. Xy plus 3x equals x squared. Okay, so implicit differentiation applies to equations that are not explicitly solved for a specific variable. Okay, so if you look at this equation, it's implicit because it's not solved explicitly for one variable like y, for example. Okay, so that's what we're going to use implicit differentiation here. All right, so let's apply the rule to this. We're going to implicitly differentiate both sides. So basically what we're doing is you're taking d dx of the left side, xy plus 3x, and then equals to d dx, which is the derivative with respect to x of x squared. Okay, so we're going to distribute this derivative to these two quantities on the right side and then just differentiate what you have on the left side. Okay, so on the right side here, to differentiate the first term, we have a product of two variables here, so we're going to use the product rule. If you remember the product rule, if you have uv prime is basically the first times the derivative of the second uv prime plus v times the derivative of the first vu prime. Okay, so this is the product rule for derivatives. So that's what we're going to do here. Okay, so we're going to have x is my u, so x comes first, times the derivative of y. Derivative of y is just 1 times dy dx plus, now we're going to do the reverse, du prime, y times derivative of x is just 1 times dx dx, okay, times dx dx. Alright, plus, now the derivative of 3x is just 3, using the constant rule, times dx dx, equals, and then here use the power rule, you're going to have 2x, the derivative of x squared times dx dx, okay? If you notice this dx dx, whenever you're differentiating with this variable with respect to the same variable, at the end of the day, the dx's cancel out, right? But if the variables are different, you do not have cancellation. So this is redundant right here. I didn't have to do this, but I just wanted to illustrate so you understand what's going on. So this is basically 1, dx dx is 1, dx dx here is 1, and dx dx here is 1. So basically when you differentiate with respect to a variable of the same variable, the dx's the d's cancel out. Alright, so on the left side here, you're going to have x dy dx plus y plus 3 equals 2x. Now, we're just going to use our algebraic rules to basically isolate x dy dx, okay? So you subtract y and 3 from both sides, so you're going to have x dy dx equals 2x minus y minus 3. And then finally, to isolate dy dx, you divide both sides by x, and then you have the wrong color. And then your final answer is going to be dy dx equals 2x minus y minus 3 divided by x. Okay, so there goes your final result. Alright, let's try another example. We're going to find question 2. Find dy dx in the equation x squared plus y squared plus 3 sine x equals 3x squared. Okay? Alright, so we're going to do the same thing we did in example 1 here. We're going to find d dx, derivative with respect to x of both sides, x squared plus y squared plus 3 sine x, And then we're also going to do d dx of the right side, which is the derivative of 3x squared. Okay? Alright, so we're going to do this term by term differentiation. The first term matches, so this is just simply going to be 2x. Dx, we don't have to write dx, okay, because they cancel out. But for this one, it's going to be 2y. dy dx does not cancel out, so we have to put it, because this variable does not match the variable of differentiation, okay? What we're differentiating with respect to. Plus, we can factor the 3. The derivative of sine is cosine x dx dx. The dx's cancel out, so we don't need that. And then here is simply going to be 6x dx, that goes away. Alright, so now let's isolate dy dx. We subtract these two terms from both sides. So we have 2y dy dx equals 4x minus 3 cosine x. Alright, divide both sides by 2y, you get your final answer. Dy dx equals 4x minus 3 cosine x over 2y, sorry. Okay, so there goes your final answer. Alright, let's try the last example on implicit differentiation. So for question 3, we're going to find dy dx in the equation 3x squared plus 2x sine y equals xy to the third. Okay, so putting my y over here. Alright, let's go ahead and do this. So what we're going to do is the same thing as we did before. We're going to do d dx of both sides, 3x squared plus 2x sine y. And then basically d dx different derivative with respect to x of xy to the third. Okay. Alright, so let's go ahead and solve this, differentiate this, sorry. So this one, 3x squared, if we use the power rule here, we're going to have 6x. Dx cancels out, so we don't need anything there. And then for this one, we have to use the product rule. This is u, and this is v. I'm going to keep these two together for u, and then that should just be v, okay? Alright, so remember the product rule, uv prime, the derivative of uv prime is equal to uv prime plus du prime, right? So let's do that here. So u is 2x, and then the derivative of sine y is cosine y dy dx, okay? Dy dx. And then if you want to do vu prime, it's going to be plus sine y, and the derivative of 2x is just 2 dx dx cancels out to 1, so you're just left with 2 sine y. On the right side, we have to use the product rule again. Let's call this is basically my u right here. That's my v. So for the uv prime, we're going to have x times the derivative of y to the third is 3 y squared dy dx. Because the variable of what we're differentiating with respect to is different from y, so we have to have this dy dx there, plus vu prime is going to be y to the third times the derivative of x, which is just 1, dx cancels out, so you have that. Okay, so we're just going to collect the dy dx's together, put everything else on the other side, and then we'll isolate dy dx. Alright, so I'm going to have 2x cosine y dy dx, and then I'm going to subtract this to the other side, minus 3xy squared dy dx equals y to the third. Now this one has to be subtracted from both sides, minus 6x, and then the 2 sine y likewise, so minus 2 sine y. Okay. Alright, on the left side here, I can just factor out dy dx, so I'll have 2x cosine y minus 3xy squared times dy dx, since that's common to both of them, equals y to the third minus 6x minus 2 sine y. Alright, so finally, to isolate dy dx, I just divide both sides by 2x cosine y minus minus 3xy squared, and that'll be my final answer. Okay, so divide by 2x cosine y minus 3xy squared. Reason I'm doing that is because it just cancels that out. Alright, so 3xy squared on both sides, and this one also 2x cosine y minus 3xy squared. So my final answer, dy dx. Dy dx is simply y to the third minus 6x minus 2 sine y divided by 2x cosine y minus 3xy squared. Okay? End of story. Alright, thanks for paying attention to this clip. Do subscribe to my videos so you can get more updates. I hope this helps you master in your learning of the differentiation process.